now that we've seen how data flow and threads work, let's do some multi-agent programming. The first concept we need is a stream, a communication channel. But a stream is just a list that ends in an unbound variable. And if we bind this variable S2, then we're extending the stream. We can extend it as much as we want, and we can close it by finally binding the unbound variable to nil. So this is a communication channel that we can use to communicate between two threads. So the first thread will add elements to the stream, and the second thread will read the stream. But these are just list functions. The first thread is building the list, and the second thread is reading the list. So here's a simple example of a program that just displays the elements of a stream as they appear. So here's a procedure disp s. It's just a list procedure. It takes a list s and uses a case to access the first element. It then displays this first element and calls itself recursively on the rest, s2. And now we declare a global variable accessed by s, and we run disp s in its own thread. Now when we bind s, we're adding elements to the stream, and this is considered sending on the communication channel, and we will display. So if we do s equal a, b, c, s2, we will display a, b, c. And then when the disp function reaches s2, it will wait, because the case statement behaves like an addition. If its argument is not available yet, because it's unbound, it just waits. That's a general principle of data flow. So it waits until somebody else binds S2, for example, to D, E, F, S3. Then it will display D, E, and F. And again, it will wait, but this time on S3. So I strongly suggest you try this for yourself. Now, let's make a producer-consumer program. So a producer generates a stream of data. It produces data. A consumer will consume the data. So the producer prod n here is a function which creates a list starting with n and continuing with n plus 1 and so on. I've added here a call to delay 1000 to slow down the execution. So the thread with the delay 1000 will wait for 1000 milliseconds when the delay is encountered. It has to be slowed down, otherwise it's too fast and we can't see it. So the consumer just reads the stream and does something. For example, we're just going to use the disp procedure we saw before. So our complete producer-consumer program looks like this. We have one thread which is producing a stream, s equal prod 1, and another thread which is displaying it. So this is a program with two concurrent agents. So we can visualize it like this with a graphical notation. We have agent P and agent C, producer and consumer. Agent P's definition is here, thread s equal prod 1 end. Agent C's definition is thread disp s end. And S is the communication stream linking the two agents. So each of the circles, each of the agents, is a concurrent activity that reads and writes streams. Now here agent P is just writing one stream, agent C is reading one stream, but of course there could be more. So this idea, a concurrent activity that reads and writes streams, this is what we call an agent. Okay, so we have two agents and a communication channel connecting them. Let's make something a little bit more sophisticated. We can add more agents in between P and C. So here's a transformer agent, or more precisely, the definition of the functionality of the transformer agent. This is a list function that reads a list and creates another list. What it means is it has an input stream and an output stream. So it reads the element x and then creates a list with x times x on the output. So now we have a program with three agents, our producer agent, our consumer agent, and in the middle we have the transformer agent running in its own thread. So in the graphical notation it looks like this. So we have now the three definitions, three agents, P, T, and C, and two streams connecting them together. Okay, three agents, producer, transformer, consumer, and two streams, S1 and S2. You see how easy it is to write this kind of program. This is called a pipeline, and it's a very useful programming technique. In fact, it was pioneered in operating system since Unix, and now it's very, very useful. So we have seen that an agent is a concurrent activity that reads and writes streams. So the simplest agent is a list function, one list function executing in one thread. Notice that since list functions are tail recursive, the agent will execute indefinitely with a fixed memory size, perfect for concurrent activity. And so we finally arrive to the deep reason why single assignment is so important. It makes tail recursive list functions possible, and that turns deterministic data flow into a practical and powerful paradigm. In fact, all list functions can be used as agents. All functional programming techniques can be used in deterministic data flow, including higher order programming. So in the next lesson, we'll see more examples of the power of this model.